Hi everyone. In this video I am going to explain about the relation between the matched filter characteristics and correlation function. So here there are two types of correlations you might have studied in signals and systems or other subject like RVSP. Cross correlation and autocorrelation. Cross correlation and autocorrelation. What do you mean by cross correlation and what do you mean by autocorrelation? Cross correlation is nothing but it is the relation between two different signals. When we are writing the expression between two different signals, then we can say it as cross correlation. And autocorrelation is nothing but we are relating the same signal. That means we are multiplying the same signal with delay x of t into x of t minus tau. That is autocorrelation. And cross correlation is nothing but x of t multiplied by y of t minus tau. That is the difference between cross correlation and autocorrelation. Okay, now here we are going to have a statement that the output of the matched filter may be shown to be the proportional to the input signal cross correlated with the replica of the transmitted signal. Okay, what is that? The output of the matched filter, the output of the matched filter may be shown to be proportional to the input signal cross correlated with a replica of the transmitted signal except for a time delay t1. Except for the time delay t1. What do you mean by this? The output of the matched filter. What do you mean by matched filter? Matched filter is nothing but it is a network which improves the peak signal to mean noise ratio. Which improves the peak signal to mean noise ratio. So that matched filter output is given as it is the proportional to the input signal cross correlated with a replica of the transmitted signal except for a time delay t1. Okay, that means after some time this is going to happen, the multiplication of input signal with a cross correlation, that is that time is given as t1. Okay, so consider the cross correlation function, the cross correlation function r of t, cross correlation function r of t. Cross correlation is just r of t is the function which represents the correlation. R xx of t is nothing but correlation, autocorrelation. R xy of t is nothing but cross correlation, general representation for correlation function. R of t of two signals, let us consider y of lambda and something like s of lambda is given by. So now we are writing the cross correlation between y of lambda and s of lambda. It is given by r of t is equal to integral minus infinity to infinity y of lambda s of lambda minus t and d lambda. Okay, so the cross correlation is given by r of t is equal to integral minus infinity to infinity y of lambda s of lambda minus t. So one function we have taken direct, another function is with a delay t with the integration with respect to lambda. Now the output of the matched filter, output of the matched filter y naught of t, output y naught of t of the filter with impulse response, output of the matched filter with the impulse response. What is the impulse response in terms of frequency domain? The frequency response of the matched filter is h of f, capital H of f. That is nothing but frequency response of the matched filter. So impulse response is nothing but we are writing the same expression in time domain. So that is given by h of t. Okay, what is h of t? How it is related with the input signal? H of t impulse response is nothing but mirror image of the input signal. I already discussed this point when I was starting this matched filter. Okay, impulse response h of t is nothing but mirror image of the received signal. So h of t the input is when the input is y in of t is equal to s of t plus n of t. See, what is happening here is we are receiving a signal s of t. Actually, we are receiving a signal s of t. After adding the noise, noise may be added within the receiver or from any other source. So after noise is being added, the input signal for this matched filter we are taking it as y in of t. Y naught t is the input for the matched filter, and y naught of t is nothing but output of the matched filter. See, this is the matched filter. This is y in of t and it is y naught of t. Okay, what is y in of t? Y in of t is equal to s of t plus n of t, where n of t is nothing but noise. Okay, and s of t is nothing but received signal. Received signal. Okay, received signal has to pass through the different stages and pass coming to this matched filter as s of t plus n of t. Okay, now that output can be written as y naught of t is equal to integral minus infinity to infinity y in of lambda h of t minus lambda into d of lambda. So now we are writing the y naught of t with respect to the impulse response of that filter. With respect to impulse response of that filter, how it is expressed? See, all these expressions you might have studied in the signals and systems subject. So cross correlation, autocorrelation, and this impulse response function, how to write with respect to the input signal. So y naught of t output signal, y naught of t is expressed in terms of the matched filter impulse response h of t as integral minus infinity to infinity y in of lambda h of t minus lambda into d lambda. So if the filter is a matched filter, if it is a perfect matched filter, then I told you already what is the matched filter, what a matched filter says. The impulse response h of t is equal to s of something like t1 minus t. Okay, impulse response is the mirror image of the received signal. If the received signal is s of t, then it is h of t is equal to s of t1 minus t. Okay, if it is h of lambda, then it is s of t1 minus lambda. Just in place of lambda we will be having t there. Okay, so now the above equation becomes, what happens if you substitute this in this, what happens now? Y naught of t is equal to integral minus infinity to infinity y in of lambda, y in of lambda. See here, just in place of lambda h of t minus lambda, we have this s of t1 minus lambda. So s of t1 minus t minus lambda, that means t1 minus of t minus lambda, this is d lambda. So how can you write this? Integral minus infinity to infinity y in of lambda S of T1 minus, how can we write this one? T1 minus T plus lambda into d lambda. So if you rearrange the equation, you can write it as, you can write this equation as y naught of t is equal to integral minus infinity to infinity y I n of lambda into S of, so how can you write this one? S of lambda minus of t minus t1, isn't it? Lambda minus of t minus t1 into d lambda. So from the first equation, see here, from this equation we can write the same from this equation, take it as 1. Here we have t, so it is r of t. So now what happens? Here we have t minus t1, so now it becomes r of t minus t1, that is y naught of t. Thus the matched filter forms the cross correlation between the received signal corrupted by the noise and the replica of the transmitted signal. Okay, so what is the output of the matched filter? The output of the matched filter is forming a cross correlation between the received signal corrupted by the noise and the replica of the transmitted signal. Replica of the transmitted signal means y of t. Okay, so y of t and replica of the transmitted signal, yes, received signal s of t or s of lambda. Okay, this is the relation between matched filter characteristics and the received signal. Thank you.